Yo, what is up, guys? Welcome back. Whoops, we got episode 125 today. I think. Oh, come on, yeah, 125. This one's gonna be a really short video. It's honestly, I'll be busy today, so, my girlfriend's coming in about 40 minutes, so I'm probably just gonna do the problem of the day because I still gotta do some stuff. Still gotta, do my laundry and make my bed and do all that shit. So yeah, so we're gonna take a look at the sound here. Take a look at the Ectobuzz sound.
I choose Electabuzz!
Ooh, ooh, ooh. That's our sound. I'm gonna sneeze. Oh, bless me. Ooh, ooh, that's our sound. But yeah, honestly, this video could be 40 minutes long, or this video could be 5 minutes long. It's all gonna depend on the problem of the day. I haven't even looked at it, so let's just see what it is. If it's something I don't want to do, then we'll just stick to something else. Oh my god, bless me again. Find the maximum sum of node values. We'll take a look at it. Okay, there exists an undirected tree with n nodes numbered from 0 to n minus 1. You're given 0 x 2D array edges of length n minus 1, where edges I, U, I indicates that there is an edge between nodes U, I in the tree. You're also given it's undirected here, so we got to take that into account. You're given a positive integer k and a 0 index array of non-negative integers nums of length n, where nums I represents the value of the node numbered I. Alice wants the sum of values of tree nodes to be maximum, for which Alice can perform the following operation any number of times, including 0 on the tree. Choose any edge UV connecting nodes U and V and update their values as follows. Nums U is equal to nums U XOR K. Nums Z. Okay. So first thing is there a place where we have to start? I was going to achieve the maximum sum of 6 using single operation. Choose your edge 0 to. I'm a little confused here. Alice can. So we're given nums, right? And represents the value of the node numbered I. Take a look at the topics. Dynamic programming, green visualization, tree sorting. Select any node as the root. This is a tough question. I am getting a little bit of intuition. I don't think I can do this problem in 40 minutes. I would like to try it, but I don't think I can. We're just not at that level yet. I do have the intuition about what we should do here. If I was to do this problem, I would just start at any random node. Start at any random node, add all the edges, XOR everything, and add it up. But I don't know. I'm a little confused with the nums array here. I don't really get why. I don't get this part, how it's in relation to this. I assume that the index of this, the index of 0 represents this value. But I don't know, this is a little bit confusing of a question, but so instead, I'm gonna do a different problem. Great, we only have half an hour left now, so I do want to do a graph problem though. I feel like we haven't done a graph problem in a little while, so let me take a look at the graph theory study plan we got here. Let's do one we haven't done. Matrix graphs. Not this one. Do a BFS, maybe shortest bridge. I don't know. This looks a little easier. You're given an n times n binary matrix grid where 1 represents land and 0 represents water. An island is a 4-directionally connected group of ones not connected to any other ones. There are exactly 2 islands in grid. 4-directionally connected group of ones. Right, so 1, 1, 1, 1, 1. You may change 0s to 1s to connect the 2 islands to form 1 island. Return the smallest number of 0s you must flip to connect the 2 islands. Interesting. So my intuition with this problem is obviously, I mean, we know it's BFS, right? So we loop through every single 0 and we check, when we check that 0, if there's a 1 above and a 1, if there's a 1 below and a 1 above, then we connect them. This is a little bit tough of a problem too. I feel like there's a lot that comes into this problem. This problem in a Fang interview. So let's just get started, right? So I feel like we just gotta pick a problem. We probably won't finish this, but you know, it's alright. I'm gonna give myself 20 minutes to do this problem, which is pretty unrealistic for me. But you know, we're gonna do it. Rows is equal to the length of grid, right? We got cols is equal to the length of grid 0. Let's print our rows. Okay, let's print our cols. Two and 2, right? Okay, so obviously we're gonna need some sort of directions array, right? Directions is equal to let's do up, down, right, up, down, right, left, right? So we can do our up would be -1, 0. Then our down would be 1, 0. Sorry, it would be 0, 1. 0, -1 would be up. Our left would be -1 here, -1, 0. And then we have a positive, which would be a left. Sorry, we did right. So right would be positive 1, 0. Then our left would be -1, 0. Let's just make sure that this is correct. Oh, I was right first. Wow, I totally messed that up. So here is negative 1, 0. We have 1, 0. And then we have 0, 1. And then we have 0, negative 1. So I messed that up, but we just confirmed that. Okay. We're going to need a visit array. Visit is equal to set. We don't want to be going to the same values, right? Let's do a... so here in this question that I note here, it says there are exactly 2 islands in grid, right? So there's only one that we have to find, right? So we need a queue. So let's do make our queue is equal to dq from collections import dq, right? Now we probably want to loop, right? So we do, okay, well, I guess the way we can think about this is that we can queue is first in, first out, right? So, okay. Let's do for row in rows, for col in cols, okay? We can check, well, if grid row col is equal to 0, right? We need an if here. Then we can append, q.append row col, right? So this here is we're adding all zeros, right? Because technically my idea here is that, right, we work with this problem here. We have 0, 1, 1, 0, right? Technically, we just have to find a way in order to connect the islands, right? So a way to connect the islands is if we find a 1, 1 directionally adjacent to this, we can change this to 1, and then we can make this work, right? Technically, I think a valid solution would be this as well over here. So we have, oh, whoops, 1, 0, 0. Sorry, 1, 1, 1, 0 would be a valid solution too. Let's check out this one, right? This one we have 1, 1, 3, 4, 5. Then we have 1, 0, 0, 0, oh, 0, 0, 1. We have 1, 0, 1, 0, 1. Then we have 1, 0, 0, 0, 1. Then we have 1, 1, 1, 1, 1. Right? Okay, so technically, really any of these zeros would work, right? Because what is our thing? An island is a 4-directionally connected group of ones not connected to any other ones. There are exactly 2 islands in grid, right? So there's 2 islands here. Really, to connect these, 4-directionally connected group of islands. So I don't think this would count here. Right, because we're in our BFS here, we're only going to be checking, okay, well, if 1, 1, right, we have to check, I think it either has to be, you know, it can't be like this way, right? It has to be here, here, or here, and here, right? So we can either check this way, then that's connected, this is connected, right? So that's one of the things we have to make sure of, right? So I think we append all the zeros, right? And we know what we're working with. Then we do while q, right? Then we pop q dot pop left, okay? We pop our row and our col is equal to this, right? Then we probably want to loop through for NC, new row, new col in directions, right? We would do, okay, our new row is equal to row plus nr. New col is equal to col plus nc, okay? And then we want to check our bounds, right? We have to check if they work, right? So here we want to check, okay, well, if first we want to check if they're in bounds, right? That's the first thing we need to do. Is less than or equal to new row is less than rows, and 0 is less than or equal to new col, which is less than cols, right? Because cols, yeah, it'd have to be less than, right? It can't be equal to, or else it would be out of bounds technically, because unless we'd want to do -1, then we could make this equal, but we're not going to do that. Anyway, okay, and really, I don't think, now that I think about it, I don't know if we need a visit array, right? Because technically, we're checking our bounds here, right? Okay, we're checking if it's in bounds, and then let's just do the visit anyway. And new row, new col, not in visited, right? Okay. Then we know it's in bounds, right? So now that we're working with something that's in bounds, now we have to figure out how we're going to compare this, right? So 0, 1. Oh, let's make it red. One more logged in is red. 0, 1. We have 1, 0, right? So we're checking this value here, right? And we're checking if it's in bounds. So really it's going to see this one, and it's going to see this one, right? Both of these are valid. In this case, both of these are valid because we have a 4 by 4. But in this case, I don't think they are valid. So really we're going to be at 0. We're going to check this. We're going to check this, right? So maybe we can do... let's make a res array here or something, right? We can append if grid new row new col equal to 1, then we can append q dot append res dot append grid new row new col, right? Okay, then at the end here outside of this, right, we can check, well, if the length of res is greater than 2, then we know we found something. We have found something, right? So let's do res dot, so then we would return the smallest number of zeros you must flip to connect the two islands. Okay. So we need to count. So there might be multiple flips. That makes it tougher. Might be multiple flips. So maybe we have to do a different approach, right? maybe we can check if it's equal to 1, right? So we can get rid of this. Maybe we can have some sort of helper function that can check if it's one island. But will that complexity, that might be too slow. Equal to 0. We probably need a count variable. We know that we need that. So let's do count is equal to 0. We found that. We only have 8 minutes left. Okay, let's try and get some help here because I'm not gonna be able to solve this in 8 minutes. 934 shortest bridge. They do a DFS here and a queue. Okay, so they do directions equal to this, visited set, right? They do step 1, find the first island and mark all its cells using BFS. DQ found is equal to false. Expand the first island using BFS until we reach the second island. Okay, we find the island. Expand the first island using BFS. If grid is equal to NR. Okay, that's a smart way to do it. It is a very smart way to do it. I didn't really think about that. Okay, let's get rid of this. Okay. Let's keep this code, right? Let's create a DFS function here. So they do def DFS, right? They pass in the row and the col, okay? If R is less than 0 or R is greater than or equal to rows, greater than or equal to rows, or okay, so they're checking the bounds here, or C is greater than or equal to cols, or RC in visited, or grid RC is equal to 0. Okay. We return. Otherwise, we do visitor.add RC. We're trying to find the island. That's why 0 won't exist. If it's in visited, it won't count. We q.append RC for dr dc in directions. We want to check our next value, right? DFS R plus dr C plus dc. Okay. All right. Okay. Step 1, find the first island and mark all cells. Okay, we mark all the cells. So let's do Q is equal to DQ. Okay. We have a flag here, right? When we found it. Okay. So then we go, well, for row, let's do for R in range rows. If we found it, we break. Okay. Then we do for C in range calls. Then we want to check, okay, well, if this grid RC is equal to 1, then we call DFS on it, right? Because we're only looking for the 1 values, right? Then after this DFS returns, we know we found it, and we can break, right? Now we've filled our queue with everything we need, right? Now we've initialized our count up here, right? So this is step 2. Expand first island using BFS until we reach second island, right? A lot of this code is going to be reused, I think. Roam call, okay? While there's something in our queue, we want to pop. Then we want to loop through for NR, NC, and directions. Okay. We add them together. We check if they're in bounds. If zeros less than rows is less than calls, and new row, new call not visited, we want to check, well, if it's equal to 1, right? If it is, then we want to return steps, right? Then we want to append a queue, q.append, nr, nc, visited.add, nr, nc. Okay. Then we increment our steps by run. There's something wrong here. If we can't get there, we can just return -1. We got a minute left. Okay, let's get rid of count. Steps is equal to 0. While queue. Why do they have the 4 here though? I don't get. Level by level BFS. We do row call for new row. Oh, new row, new call. Got some stuck. Oh, q.append. Where the hell am I doing that? I need to append new row, new call. New row, new call. New row, new call. There we go. So we check our queue. Then we go for something in range length queue. We go row calls equal to queue.pop left. We check it. We create a new thing. We check if it's in bounds. If it's equal to 1, we want to return steps. I don't get that part. I think I'm understanding this problem wrong. I think we have to count the number of steps to switch it. I think that's why we're wrong. Like, we can switch it in 1, but I think, yeah, that's where I went wrong. That's why I'm confused right now. That's why we're doing level by level BFS, right? Because we're looping through, right? If we see an adjacent one, we return the steps, right? So in this case, we return 1. So if grid new row new call is equal to 1, we return steps. Q.append new row new call. Steps plus or equal to 1. Okay, I'm just a little confused about this test case, but we've run out of time. I would like to analyze this further, but I have the general idea about how we solve this, and I think I probably could have solved this if I had more time, but again, I guess in interviews, you're probably not going to have that much time, so that took a good crack at it. I'll see you guys tomorrow. Appreciate you guys watching.